saying what is net neutrality, and basically this, you know, this is more than just an introduction, it's basically the results. So I have 5 different meanings I want to talk to you, and the first is net neutrality is defined by strictly equal, meaning identical treatment of every data packet at any router, meaning that there are no specific priorities other than random, especially no quality of service procurement. This is basically what some proponents of net neutrality are saying. This is the right definition. I doubt that. So the second one is net neutrality is defined as equal treatment of every sender paying the same price per data packet, getting the same priority, meaning basically same average quality. So different prices for different priorities as by the choice of the senders. This is important. It's basically the senders are deciding on the quality they want to have. So there are 3 different meanings. One is different treatments of services. So this is not net neutrality in a sense, but it's a way of talking about what we can, how we can handle this. Different treatment of services, paying the same price per data packet by technical functionality. So some networks handle voice over IP packages other than other services in order to make them function. But they won't if we would not have special treatments on the technical side for that. And or by assumed value judgments done by network operators. This is what I would call a non-price prioritization. The fourth, different prices for different services for the same priorities as by willingness to pay or as by price elasticity. This is the classical price differentiation or price discrimination, which is the same in economic terms. Not in legal terms, but in economic terms, price differentiation and pricing is exactly the same thing, meaning that for the same, basically the same service, you pay different prices depending on who you are, how you get it, and so on. The fourth one is different treatment of services, paying the same price per data packet, basically if the price is 0, which it mostly is, for the reason of protecting one's own services, basically telephone service, against competing services. For example, voice over IP services. And this basically have been the case that people are worried about. And you can differentiate this in competitive markets, oligopoly markets, and monopoly markets. And the red here basically indicates that this is not allowed in legal terms and is also not okay in economic terms. Do not talk about that. What I basically want to do is talking about the differences between number 1, which is basically the understanding of a lot of the internet community, and number 2, which is the definition I think is the right one. So the comparison of the 2 is basically the core of the argument on net neutrality as I see it. These 2, right? So the first one is the basic problem is a problem of congestion, meaning that there are more traffic than capacity available. And I do not have to talk here about the internet traffic growing. You all know that as least as I do that. And technically, as soon as we have more data packages arriving at routers, we have 3 different things happening on the data package level. You may have delay or latency, you may have jitter, and you may have package loss, meaning that packages are just going somewhere or nowhere. And the problem is basically that on this level, of the technical level, you have a direct rivalry among different packages. deregulation exactly means that you cannot have all of them. You only can have the number of packages the router will be able to carry. And the basic problem economically is that this leads to a specific form of partial rivalry at the service level. Partial rivalry means that you may carry more, but the quality is going down. This is the same as you experience that it's congestion on streets or airports and so on, yeah? So, a basic problem for all of these is, as we experience it now, first, that most of the users have flat rates, meaning that the marginal cost for the user is zero. As economists, I would say, despite the fact that the costs are not zero, the marginal costs for the system are not zero. So this is basically, what we can talk about later. But for the users, the marginal cost to send one more data package is zero. And the second one is that we have net neutrality version 1, or if we have that, net neutrality version 1. Actually, we do not have that now because some networks, they manage the system in order to make it happen. But this is, from the economic terms, somewhat problematic. What I basically want to do is tell you something about congestion. And what you see here is a demand function for this one here, from here to here. A demand function for transport of data packages through a system or through one specific router. And if from a certain point on, in my figure, this is from X3, you have congestions, meaning that some data packages are going lost, or you have jitter, or you have latency. And from that point on, the quality, at least of some services, is going down. Meaning that the demand function is going from this one to this one here, yeah? Meaning that the quality is going down. And if we convert this in the specific economic terms, you have this function here, and you also have this marginal externality overload, meaning that as soon as you send more data packages into the system, you also make things worse for others. You create a negative external externality to others because of the additional data packages, and this is seen here by this function. And at least if you're economists, know that we always have the optimal point at the intersection of the marginal cost and the marginal utility function, and this is right here. So what you directly see here is that the optimal number of data packages in the system would be XC and not X7, as would happen if you do not have any provisions for this. So what you see here, this is the welfare loss if you have more data packages going through the system as would be optimal. So this is the optimal point. The problem is how to get there. And in some systems, it's not a problem because you simply have to introduce the price pre-C if you have all these functions constant, and if you will be able to really do that. In the internet, this is not simple or maybe impossible at all, but this is a reference point for economies at least, that this is the optimal usage here. Yeah? And the problem is how can you prevent other data packages from this side here to enter the system. So this is the basic problem from the economic terms. Clear is that a price of P equals 0 is inefficient, because in this case you would have too many data packages going through the system, deteriorating the quality for all the users in the system, at least at specific times. So what I'm talking about here is that the overload does not happen all the time. It basically happens at specific hours a day, basically at the prime time hours and in the prime time at specific situations. At the time now where the network operators invest in over-provisioning, you may have the problems only for minutes or an hour or whatever, you don't have it all the time, but at specific times, and the figure I was showing is referring to specific situation. So the problem now is that when I'm talking about quality is going down, this is not correct for any service, because some services do not react at all, because they can handle that without any quality deterioration, whereas others, are going down with their quality very dramatically. And this is the basic problem, I think. Meaning that the heterogeneity of the level of the services and applications. This is the problem, and I'm talking about that in my next section. So, the different internet services, I categorize them in 3 different characteristics or different factors. The one is the quality sensitivity. Some are quality sensitive in the sense that if you have more data packages than the routers can handle, the quality is going down or is going down dramatically. And there are other non-quality sensitive services. They can handle it without no problem. Downloads, peer-to-peer, music, videos, etc. They simply, they send them afterwards and they put them in and no problem occurs. So these problems, these services are not quality sensitive. The data rate is very different. Some, simply are very low data rate, and some are very high data rate services, especially things like videos, music, and others. And the economic value is very different, and the economic value is defined here in the term of willingness to pay for data packet. This is my criterion. So when I'm when I'm talking about the value of services, and I'm making judgments on different services about their value, I always mean that the willingness to pay for a simple data packet. This is important, not for the service as a whole, but for the simple individual data package. And it also, you could transfer that, if you want to, in revenue potential for the network operators or in consumer rent. This is just a way of different. So this is just a figure showing that they are different, differently organized. And this two of the three criteria. And basically, what I'm doing now is I am talking about quality sensitivity, low data rate, and high data rate quality insensitive services in the following. So this basically shows that for some services, the quality is going down from an initial 100% to very dramatically, and some are simply, insensitive to these things. I would now like to contrast a D1 and a D3 service, where the one is the quality sensitivity very low, the economic value is very low. For example, downloads, peer-to-peer, file sharing, music, videos, and etc., YouTube. Yeah? And another service, D3, quality sensitivity high, meaning that the quality of the service is going down as soon as we have overload. And the economic value is high, meaning that the users are willing to pay high prices for data packages like interactive services, voice over IP, IPTV, number of business services, and so on. And if we have that, we have a demand function here and a demand function for the other one here. And what basically happens is if you have a file sharing platform and this is consumer advertised, So, and this is the hypothetical consumer rent in the first time, and this meaning here 4. You compare this for the next charter in terms of quantitative judgments here, and this is basically the consumer rent of advertisers. Yeah, and basically what we will see now is if they have incentives to grow in terms of data packages, the problem will arise. So the first thing is, if we are talking about this here, and this is a directive business services like voice over IP, where I saw this here, and this is just a normal revenue for a business company that is making profit on these services, and no matter if this is advertising, finance, or so on. And so what happens here is that the demand function here, the demand function is going to, on this side, because the advertising finance services have a strong incentive to grow in terms of number of data packages. As soon as this happens, and we are coming to a point where the congestion, the overflow occurs, at that time the quality is going down for this service in this direction here, because as soon as you are no longer able to see the TV show in the right quality as you know that, or the business services are not functioning in a way as you expect that, you are not willing to pay as much as before, and you may simply do not want to use it at all, basically meaning that the demand function for this valuable service is going in this direction, or may just arrive at a point where it's not cover its cost at all, and so the service would be shut down at all. So this is not a scenario that happens at 100% of all internet traffic, but it's a more kind of a specific situation I want to argue about. So if this happens, then you have a crowding out of high-value services, for this one here, by low-value services. Low-value service, for example, peer-to-peer file sharing and for music and videos and so on. So, and these file sharing services, they have very low value in terms of willingness to pay for a simple data package, because as soon as there are any kind of prices, it's simply not longer okay for the users to do that. They could simply buy the video or buy a CD or something. Yeah? So these are not able, from the point of view that they are illegal is a different point, but it's not important for economists. The legals may say, well, that's illegal. It is, but for economists, that's not a problem. So what I'm basically saying, if crowding out occurs, this is directly a problem of the specific situation of flat rates in the internet and a improper meaning of net neutrality, meaning the first interpretation I was talking to you about in the beginning of my talk. Yeah? So I want to discuss 3 potential solutions for this problem. One is over-provisioning, the second is a price per data package, and the third is priority pricing. So the first one is over-provisioning and optimal capacity. Over-provisioning basically means that you always, or you say to the network operators, you always have to have capacity of your networks that whatever happens, any data package must go through without any data, without any latency or data packet loss. This is meaning that you have to over-provision your system in a way that there would be no congestion problem at all at any time. Every economist would say, well, that's nice, but it's costly, of course, right? So if you, this is the question of what is optimal capacity in this case. And if I apply my theoretical setting from the beginning to this case here, meaning that this is the situation before, and this is the situation if we have a higher capacity, if we have invested in more capacity in routers and lines. This, what you see in brown here, basically is the welfare increase by the investment in more capacity. So if you transfer this into my next figure, meaning that this is the total utility if you invest more and more in network capacity, meaning it's going up here, up to a specific point from where on, you know, the situation is such that there would be no there would be no congestion at all. So the value here remains at the same price. And what is important for economies always is what is the marginal value for higher capacity. And this line tells this here. This is the long run marginal utility cost. Yeah, it's going down here, of course, and it's zero at the point where more investment wouldn't gain no more value. And so this is the marginal long run marginal value function or utility function. And we have to look at the price, at the cost situation. And the cost situation, we are asking about the investment cost for more internet capacity, and basically for the value, the marginal value, the marginal cost function. And this is here. It's assumed to be constant. It might or might not, but it's easy for me to just assume that any more routers would simply cost the same as the one before. And if we had that, so this would here be the optimal internet capacity. What we have, if we want to have the highest quality of service, we're talking about later today about quality of service. If you want to have everything at the highest level, then you would ask to get here. But this would not be optimal. The optimal point would be here as soon as capacity is costly. So this would be the over-provisioning point. Basically saying, I say, well, over-provisioning is the wrong solution to the problem. Second solution, potential solution, is let's have prices for data packages, meaning basically we're going away from flat rates. So we're talking now about having quantity-related prices for using the internet. We certainly would have to have that in a way that we should have different prices at different times of the day, because the usage would be different. So we should have, if we accept this solution 2, a system of peak load pricing. As soon as the price per data package is greater than 0, we should have a price, and we have marginal cost greater than 0, because from a specific point on, we have the deterioration of services by getting more data packages through the system. So this is the point here. If we have for a specific situation a price PC, if we could do that, then we would have automatically the optimal internet users XC. And if we could do that, everything would be fine, and I could stop my talk here. But unfortunately, this is not the case here for specific reasons. One is just a normal reason of measuring, and there is another reason which is even more complicated. So I'm talking here just about peak time situation here. So in general, I would say, well, this is the optimal solution, like in highway traffic situations and so on. As soon as we know the usage patterns precise enough, we could just imply a peak load pricing system and everything would be fine. This is a little more complicated here. So the first is that what you always need if you introduce a price system, you have to introduce a price after you know what the usage pattern would be. You must have a somewhat valid judgment on what the demand function would be, or how many users want to use a street or the internet at 8 o'clock in the morning, or at 8 o'clock in the afternoon, or at 9 o'clock in the afternoon. So you have to have a somewhat exact judgment. If you do not have that, you have a problem. The second is, the price system must give a signal to the users in a way that users react on a specific price signal, saying that if the price is high, they might say, well, you know, it's too expensive for me, I wait for a while. And others just react in the opposite way. And this is not the case in the internet. Very many peaks are basically, you know, not, you cannot know that before. And the second one is, the quality sensitivity is very different among services. And this is a main problem here, because as soon as you introduce a price higher than 0, some services simply would be thrown away. You know, any file sharing services, any download of music and video simply would disappear from the internet, because they would not be able to afford this here, or they would simply buy videos or CDs in the store. So, and this, you could say, well, if they want to pay the price, no problem, you know, they simply disappear. But this is inefficient here, because these services, as long as they are quality insensitive, they might simply wait for a while, for some seconds or even minutes, and then going through. And you would avoid this by given a fixed price. Yeah? So this is the problem here. I call this very short run overload situation. So they simply use coming up time slots. If it's crowded now, some download data packages simply wait for a while and then going through, or they are ordered to send back a second time or third time or fourth time. No problem for the users, and then they would go through, saying that this would be just to wait by lower priority. And this is the third solution, priority pricing, and this is the one. Priority pricing basically means that you put different prices for different priorities for being served, saying that you can choose if you want to have high priority for your data packages and that you pay more, or you do not want to have high priority or no priority at all, and then you, in case of overload, you have to wait for a while. Yeah? And some, as you surely can imagine, some services would always be willing to pay high prices because the services won't work at all without going through immediately, and some services won't pay for priority because it's simply no problem for their services. So the basic thing is how to do this. This basically means that at the if you are on the router level, the packages A or B of different services, this is the point, the technical point for the data packages. But if you apply a priority pricing system, then you might have A and B, because some of the servers are going through immediately and some simply wait for the time when you have more capacity available to get to leave these through. So the economic effect of this system would be the internet capacity for a longer time, not for seconds or milliseconds, so let's say for an hour, for a day, or for a week, would be higher, would be increased without infrastructure investment. You simply can increase your capacity without investing, simply, because you use more you use your internet capacity more efficient in a way that you have more time really use the way. So basically, this is the difference here. This is the one utility without priorities, and this is with priorities, and it's more different as okay. So my time is always over, so I want to just coming to my last figure. The result is, if we contrast these two interpretations of net neutrality, I would say that this one here, you know, might be nice if you don't know much about economics, but from the economic standpoint, it simply is not efficient. Net neutrality, in this sense, I always would say, well, net neutrality is a good thing, because this, you know, would work in a way that we arrive at economic efficiency. Thank you for your attention.